All right, let's dig into a bit of a mystery today. We're going underground to figure out what invisible forces can stop a perfectly healthy plant in its tracks. Even when it seems to have plenty of sun and fertilizer. The answer? Well, it's often hidden right under our feet, in the very soil that's supposed to be giving life. I mean, it is so frustrating, right? Especially for a farmer or even just a gardener. You feel like you're doing everything by the book, but the plant just looks sad, stunted, weak, maybe a little yellow. You go looking for bugs, for diseases, but sometimes the real culprit isn't alive at all. And this picture, wow, it just says it all. Take a look at this root system. See how it's all shallow? It's spreading out sideways, but it is not going down. Those roots have slammed into an invisible barrier, a literal wall of dense soil that they just can't push through. And that is the absolute heart of the mystery we're talking about. So these barriers have a name. They're called restrictive soil layers. To put it simply, they're these super dense, compacted zones in the soil that basically act like a layer of concrete. They physically block roots from growing, and they choke off the movement of the essentials, like water and air. Now, the main bad guy behind most of these layers is something called compaction. The best way to think about it is to imagine squeezing a wet sponge as hard as you can. All those little air pockets and channels for water, they just disappear. Well, that's exactly what happens to soil. Outside forces press the soil particles so tight that there's just no room left for anything else to get through.
So how does this happen? Well, a lot of the time, we kind of have to look in the mirror. We're the ones creating these roadblocks, especially with the way modern farming works.
There are really two main ways we cause this compaction. The first one, wheel track compaction, is pretty obvious. You've got these massive, heavy tractors and combines, and their weight just crushes the life and the pore space right out of the soil. But the other one is a little sneakier, tillage-induced compaction. This happens when you use tillage tools, like a plow, at the exact same depths over and over again, year after year. This process creates a very specific kind of restrictive layer. We call it a plow pan, or sometimes you'll hear it called a plow sole. The smearing action from the bottom of the plow, plus all that pressure, basically forges this dense, almost waterproof layer right where the tilled, fluffy soil on top ends. And what's so great about this diagram is how clearly it shows the consequences. Look, you've got this beautiful, loose feed bed up top where you want the plant to grow, but right underneath, there's that plow sole. So when it rains, water hits that layer and just stops. It pools up, waterlogging the topsoil, while the deep subsoil right below it can stay bone dry. The roots can't get through to that water, and the top gets suffocated. It's the worst of both worlds.
And it's not just a problem deep down. Right at the surface, a heavy rain can actually hammer the soil aggregates apart. The tiny particles wash into the pores, and when it all dries out, it forms this hard, brittle crust. That crust can literally stop a tiny seedling from breaking through to the sunlight, and it also prevents the next rain from soaking in.
But hey, we can't take all the blame. Sometimes the soil itself has its own natural, built-in barriers that have been forming over thousands, even millions of years. And these natural hardpans have some pretty fantastic names. You've got fragipans, which are dense and brittle. You have duripans, which are literally cemented together with silica, think natural glass. Clay pans are exactly what they sound like, a super dense layer where clay has built up. And petrocalcic horizons are cemented solid by lime. The key thing to remember is that lots of different natural processes can end up creating these root-blocking layers. Okay, so whether they're man-made or natural, we've got these hard layers. But so what? Why are they so absolutely devastating for plants? Let's break down that chain reaction of damage. It really is a domino effect. It all kicks off with losing that pore space. That immediately chokes off the movement of water and air. Without air, roots can't get the oxygen they need to live and work. They literally suffocate. At the exact same time, they are physically blocked from exploring deeper in the soil. And if roots can't grow and they can't breathe, well, they definitely can't take up the water and nutrients the plant is desperate for. This quote just nails it. It's simple physics. If the little pores and openings in the soil are smaller than the tip of a plant's root, the root can't get through. End of story. It's just as final as hitting a brick wall. Now, I know this all sounds pretty bleak, but don't worry, it is not a lost cause. We have some really powerful strategies for both breaking through the layers that are already there and, even more importantly, for preventing them from ever forming in the first place. This really is the million-dollar question for anyone who grows things, right? How do we fight back against this invisible barrier and get back the full potential of our soil? Well, The most direct approach is pretty much brute force. This machine is a subsoiler, or a ripper. It's basically a giant metal claw that gets dragged deep through the soil to physically shatter that compacted hardpan. It's a tough job, but it can be incredibly effective at ripping open new channels for roots and water to explore. However, ripping is expensive. It burns a ton of fuel, and honestly, it's just a temporary fix if you don't change the practices that cause the problem. The best strategy is always prevention. And to prevent compaction, you just need to burn 2 words into your brain: timing and traffic. Okay, let's talk timing first. This graph here, the Proctor curve, is so important. It shows something a little counterintuitive. Soil is most vulnerable to compaction not when it's soaking wet, but at this optimum moisture level, when it's just moist. At that point, the water acts like a lubricant between the soil particles, letting them slide together really easily under pressure. So what's the big takeaway? If you can help it, stay off the fields with heavy equipment when the soil is moist. And that leads us perfectly into the second word: traffic. If you have to drive on the field, the smartest thing you can possibly do is control where you drive. This is the whole idea behind a system called controlled traffic farming. You set up permanent lanes or tram lines for all your machinery, and you stick to them every single time. And these pictures show you the result. It's brilliant. You basically sacrifice a small part of your field to be these permanent, compacted highways for your equipment. But in exchange, the huge majority of the field, the beds where the crops are actually growing, stays loose, healthy, and totally free from compaction.
So the next time you see a plant that's struggling, don't just look up at its leaves. Think about what might be going on underneath the surface. A simple shovel can tell you an amazing story. Is there a hidden barrier down there holding that plant back? Understanding these unseen layers really is the first step to unlocking a much healthier and much more productive soil.